So my topic, I call it Thirst-Quenching Streams for the Reactive Mind, this really is going to be about streams. And streams can mean so many things, but within the context of Java, reactive Java is what I'm focusing on today. Just a note too is that obviously we're a Java conference. So I've been to conference in which it was conferences that were more like general purpose. So I always kind of wanted to make sure, okay, this isn't about React JavaScript or React Native, even though there are some conceptual common understanding between these libraries and frameworks. But today, though, we are going to be talking about reactive Java. And although I have to say too, concept-wise, it applies to all, but it's just more like the examples I'll be using will be more like all Java related. So as such, I won't introduce myself again because Sandeep did such a great job. Thank you. So let me kind of start a bit. It's only 30 minutes, so and still too, I wanted to make sure everybody comes in, with some kind of common understanding. So I'll be talking a bit about some concepts too. So bear with me if you already know, but assuming some folks are new to this. So so I wanted to kind of categorize it too. When we talk about reactive in Java, there would be the reactive programming side, and then the reactive systems, and also reactive streams. So let's start. Reactive programming, a very common way of describing it, and I'm borrowing it, is from the RX marble diagram. So RX is the reactive extension, and basically using marble to describe. And essentially, to reactive programming, we're talking about streams programming, leveraging on the functional way of processing that approach. Although I also have to say too is that reactive functional programming is not exactly the same as functional programming, even though, yes, reactive makes use of the functional paradigm to do things. The thing is, the one big difference is that in reactive programming, what actually makes your program logic flows, we are focusing on the data part. So the data flows whenever there's state changes, it flows. So it's a bit more like a higher level kind of concept. Whereas like for functional programming, it's a bit more lower level. We're talking about the thread like control, so the execution. So the thread of control as it kind of goes through, and that's how you move your logic kind of forward. So back to this. So RX marble, they're using like streams, these streams to describe it, using marbles to describe. So this one, the first top one, is just a stream and no events. And of course, too, when we talk about reactive programming, we also are talking about events because it's asynchronous style of programming is very different than traditional imperative style. So we're talking about streams, then there are events, and these are represented by marbles. The second one, you see that there are marbles, and then there's like a perpendicular line. It signals a streams that has a definite time to it, so it terminates at that point. And then the third one is some error that occurs. So that is actually represented, basically it's managed as an event too for any error. So in this kind of way of programming is that even error events are first-class citizens. So it needs to be handled accordingly. Unlike if you do imperative style, then there are different like errors and you have to catch them and handle them differently. Well, you still need to handle, but they are just more first-class citizen in the reactive kind of space. And then the bottom one is a stream with like an infinite kind of an open-ending stream with events that are happening. And just some quick example too, using RX marbles, and how do you work with the streams of data is essentially in the reactive extension way of doing things. And that's also too is not just reactive extension, but there are other libraries too that we talk about operating them. So these are like operators that we operate on the streams. And so using RX marble diagram, using the like a basic, very commonly used function, this would be using a map, and the map will do a transformation. It basically takes in your function definition and transforms the data accordingly. So in this case too, if you see it in the code, then it would be observable. Using RX extension, observable RX Java 1, which doesn't have support for backpressure, which I'll touch upon in a little bit. And the thing is, observable, you basically manage your stream doing a .just. In this case, kind of process your input data, then apply your operator .map, and your function says multiply by 10. And then the thing is, with your client, you can see too, this style of programming is very efficient and elegant, because you immediately, then your client is subscribing to the result there. In this case, like doing a .subscribe will essentially tells it, it's basically signal. You're subscribing to a data that will happen in the future. So when you subscribe to it, it's basically things happen in the future, and when it's ready, then what it will do in this case is just print out the result. In this case, is item 10, 20, and 30 for like 3 events that carries itself data 1, 2, 3. So you can visit rxmarbles.com to see more examples, and there you can also try them out, a lot of interactive kind of exercises. So now then, when it kind of moves to reactive systems, especially in Java, whenever we talk about reactive systems, we cannot be forgetting about this Reactive Manifesto, which actually is an initiative, kind of guidelines led by Lightband, the company that makes Scala, Dr. Martin O'Dursey's company. And so these are like the 4 tenets of what defines a reactive system. So namely, like systems have to be very responsive, and meaning that any requests come in, it needs to be handled in a very timely manner. And then there's also the elasticity, or maybe let's do clockwise. So we go down, there's resiliency part. So by being resilient, it means that if there are errors that occur, it needs to also be handled in a timely manner. It needs to be able to recover kind of without too much causing any havoc, essentially. So in today's world of like cloud and clustering technology, it's basically reactive. To me, I feel that as I'm understanding and working more with reactive systems, I realize it's kind of like kind of like the stars are all aligned. What used to be was that, okay, go back a little bit of history. As we all know, there was there was like a single CPU, single core machines. And so at that time, right, your threads are all being handled in the main like kind of kernel space. So that's the idea too of reactive, is that it comes in, it's basically, they're still threading, but the threads are being handled in the user space versus in the kernel. So then you don't really hold up the main thread when you do things, right? You can kind of, enable like your asynchronous processing to be more efficient. So anyway, going back then to the resiliency is that, if there are problems that occur essentially too, in the clustering environment is kind of cool too. Some of the, say Kubernetes or any kind of library, Akka, for example, it basically too, you have components that can be spun up to kind of overtake whatever, is sick. Some child node is sick, and you kind of have another one that pops up and take care of things, and the system needs to be able to recover quickly, essentially. That's what it is. Okay, so that was like a quick nutshell about that. And then if we go left, then there's the elastic property or scalability. So in any given time, right, your systems could be like hit with a lot of traffic, a lot of requests. So doing that, then your very reactive systems would then need to have a mechanism or resources to spin up and handle all of these additional volume of data, the stress that is experiencing. So that's kind of elasticity. It basically deals with the scalability of your system. So that, if let's say too, if times of kind of quiet time, then you want to also kind of save, your energy too. So you spin down some of your services, and or they can also be used for handling other requests too. So that's elasticity. But also a good example to kind of explain that would be like Valentine. I like to use this Valentine's Day before Valentine's, and like a flower shop is going to get tons of requests coming in and order that. So in that kind of scenario, we do want the system to be still stay responsive by being very elastic and scale up kind of accordingly. Okay, so that's that. And then all of these are possible because of a very message-driven nature of a reactive systems. So we're talking about components that are all like isolated. They are not tightly coupled. But yet, amazingly, too, in a reactive systems way, too, is that a system as a whole still needs to function in a very coherent fashion, even though individually all of the components are operating on its own, but when it called upon, they need to be able to kind of interact with one another without clashing with one another. So that's kind of like, high level thing describing like message driven kind of capability. And also too, it's not exactly the same as like event driven. Message driven are dealing with like messages that are usually it's you send to some messages to some known endpoint. So your address, you know where you're going to. But for event-driven in general too, it's events happen, and it's really up to whoever is interested in it will subscribe to the messages that will be emitted by the source. So it's kind of like that aspect is different too. All right, then let me kind of quickly move through this. When we talk about reactive systems, what it's trying to address is really concurrency and living in a world of multiple things that are happening. To me, I feel that like the world is definitely getting to be more and more complicated as we all know it. So many things are happening all at once. We're all juggling and different things are going on. So concurrency is the thing that I feel, going forward, all of the systems would be focusing more on handling this aspect of computing. Say, for example, like Project Loom that comes out of the OpenJDK kind of initiative, the Java committee, JSR, and the Project Loom will be handling with virtual threads, for example. And so that will be an area we can kind of talk more about too, but that's kind of excites me, right? Some of these things. So anyway, so we're then talking about, reactive is really dealing with concurrency and handling things in a very different way than traditionally. For example, we're dealing with a lot of callbacks in the past, but now there's still callbacks. The callbacks are happening on the lower level. We're abstracting out all of these things. And so on the higher level, we have better mechanism of handling this. So then as, we're developers, we're building up applications for the, business layer. We don't have to deal with as much of the lower level stuff. I mean, while they're fun to do, as computer people, we love doing these kind of challenging things and kind of small little kind of algorithms. But really, it takes away time from kind of solving problems on the business side, which can be just as challenging and also different, right? So anyway, so that's the point it's trying to do. So just a quick thing is that concurrency is really dealing with multiple tasks all at once. And parallelism also is doing multiple things, but parallel processing really requires hardware because you want to do multiple tasks all at once. So in a multi-core hardware, then you have different cores like handling things. Maybe they're repeating the same thing, or different things too. They are all being done in parallel. But whereas concurrency, it gives you an impression that it is doing things in parallel. But let's say, you have limited core, then you still need to kind of take turns like handling things, right? You need to like, kind of give up your thread, for example, and processing or something, and you need to like switch between them, but giving you an illusion that, okay, it is kind of handling things in parallel. So that's just some basic thing. Okay. Now, some reactive architecture design patterns. These are some of the common ones that we come across. But of course, too, there are a whole list of description of all of these reactive architecture design patterns. So the thing I want to point out is CQRS is, well, actually the order I should have changed. But anyway, let me kind of quick to talk about backpressure. Backpressure is essentially what Reactive Streams is trying to address. Backpressure is when you have a systems having, too many requests coming in, and if it can't handle it kind of on time, then you essentially, the pressure, you're trying to go forward, and it's kind of turn back, the pressure comes back. So it's back pressure, meaning that, your system actually needs to be able to handle requests and not kind of choke your system and have the pressure kind of turn back on itself kind of thing. So that's back pressure. Then there's also circuit breaking. So if you're a physics person, then you're very familiar with circuit board and circuit breaking. Essentially, if there are any errors that occur, then you want to kind of break that kind of link and not have it hold up the rest of your system. So circuit breaking is another patterns of a reactive systems. And then go back to here, then event sourcing. So event sourcing is also like a common, or kind of a bit becoming more common patterns, I'd say. It doesn't have to be applied to reactive systems alone, but it can be like non-reactive too. But the thing is, event sourcing is becoming a bit more popular. It's essentially your source, instead of like, say, in the database, you kind of record your different like or your data, but you basically are recording your events and the data at that point in time, and you keep a kind of a log of it. So then if any point in time you want to look at what the data is as it goes through time, you can actually do a replay and kind of go through your events again and do a replay and figuring out the state of data, how it changes over time kind of thing. So, okay, then there's CQRS, which is command query responsibility segregation or separation. So this is like separating the write API with the read API is what it is. So again, I won't go into all the details here, but there is also a link that I would point out to you. And over here too, then let me move more then into, I realize there's also limited time. So, so there's also getting into reactive streams. So then there's streams processing. So there are two models fundamentally, push versus pull. So push, when we talk about streams, push kind of model, it means the upstream data producing data, it will push the data to the downstream. So it's basically source to consumer, kind of push, it gets pushed down. But for pull, it's really downstream, like pulls the data from upstream. It's also called like code observable for this one in a more reactive extension kind of terminology. Then the push is hot. So essentially hot is kind of a non-lazy way, so to speak, right? There, your data that comes, it just push accordingly. But the pull is the cold, it's more lazy. It's you're doing a dot subscribe, for example, will be kind of like a cold observable. You pull it, you tell the upstream you need something in the future. It will, it pulls it. But there's actually very often in a reactive streams implementation, it's more like a pull than push because it's more like whoever needs it, you do a subscribe. Then when the data is ready, it will get pushed to the consumer accordingly. Okay, so just quick thing, producer emits data. It sends without being asked explicitly, that's more push. And pull is downstream initiate. Consumer needs the data, it's in the future. So when producer is ready with it, it will emit the data accordingly. Backpressure, that's just an example of talking about too many requests coming in and the pressure kind of builds up and it kind of turns back towards where the source is what it is. So this is another example. I thought it's kind of funny to kind of describe like backpressure to publisher, publishing too much and the subscriber just cannot process it accordingly. So. All right, quick thing to get into like reactive streams. There are four, essentially the interfaces. There are no implementations for it. So now again into reactive streams, they are really a specification formed, is basically backed by the reactive foundation now. And I'll go a little bit into that in a little while. But essentially is four interfaces: publisher, subscriber, processor, and subscription. So this is like the Java interfaces for it. You can see too, there's publisher, subscriber, then there's also subscription. Subscription essentially describe the relationship once a subscriber has, basically kind of associate with a publisher, then there will be a subscription. And that's where backpressure support will happen in the subscription too. And then there's also a processor that basically kind of essentially it interface that is for like processing the streams. Right? Okay, so now then let me move into a few popular reactive libraries and toolkits that I will also kind of quickly give some examples to in the next few slides. And so Vert.x, and let me kind of start with Vert.x. That's an Eclipse Foundation project, and it's very interesting. I actually will have some code, so I won't go into all that example in here or all the examples here. There's Vert.x, and then it has its own event bus, and it's very efficient and everything. And then there's also MicroProfile, which is actually also an Eclipse Foundation project. And actually, the reactive library is making use of a new one, a relatively new one called Mutiny. It's actually associated with Small Rye. I think Small Rye started off, and then now it's just a labeling. That's how the developers call it, Mutiny. So that library, it's also it has its own set of operators, but it's much more streamlined when compared with the reactive extension one. And it's also supposed to be more or less confusing and more efficient. It does not have like map, this common like map or filter map and all these things, or I shouldn't say filter map, but the flat map, I'm sorry. So it's just that it has like greatly simplified the way operators work is what it is. And then there's also reactive extension, Project Reactor from the VMware, from the former Pivotal folks. Then there's also Akka from Lightband, and we see this group of libraries. And then there's also, I wanted to still bring up without ignoring, is the Microsoft library called Orleans 2. It's of course, that one is more, it's not for like the Java side, so to speak, it's more for .NET, but I wanted to also bring that up. And then there's also RSocket, which is like the latest, a bit of a newest kind of library, but it's more like lower level. It's for layer, the networking protocol layer 5 and 6, and that's RSocket. So, okay, so now let me get back a little. Reactive Streams, and so this is the class, the arc.reactive streams API, and their specification only, there are no implementations. And there's also any library vendors want to implement it will have to pass the TCK test, right? That's the test compatibility kit, I think, or technology compatibility kit, one of the two. But so it actually has a specification as such is now overseen by the Reactive Foundation, which is a consortium of 6 companies or even more at this point. So that's the Reactive Streams specification. And there's and there's the idea of Reactive Streams is basically defined as standard. So it encourages like interoperability between different implementations. And also one note to note is that we do not encourage people to do their own implementation of the Reactive Streams because it is actually very complicated if you're kind of designing and trying to write libraries on that level. So very often we're encouraging folks to use libraries that are already out there, as I have mentioned earlier. So, and then the nice thing is that I feel that there's also a lot of possibility, right? If you're making use of any libraries that support Reactive Streams, you can basically have a very hybrid implementation of your systems of different pipelines made up of different library implementations, because as long as they conform to the Reactive Streams, they can all, the pipeline, you can basically link them all together and maybe have a Kafka stream as your source and you know, have some topics, you subscribe to it. And then you kind of have the whole pipeline be built up by different, you know, kind of implementation accordingly, because you're handling different parts maybe of your company, different, you know, teams are doing things differently. So there's a way of everybody cooperating through this specification. So, all right, this actually will be kind of, I'll just quickly kind of run through this because let me also, I realize I only have 5 minutes. It's always when there's like 30 minutes, I always kind of go a little bit kind of deep into, too deep, but anyway. So Spring Reactor, I have gone through, and Reactive Extension, we have also gone through. Vert.x, let me give you the example in the next slide, and Akka Streams, and that's interesting. Akka Streams is I want to kind of point out, as we know, Akka is a very sophisticated library. I feel it's very sophisticated. The design is slightly kind of different, so if I may say so. Different in the sense it's just a different approach, right, to doing things. And it's completely decoupled in their Reactive Streams interfaces because they wanted to further simplify it. So they kind of abstracted another level up. So that's Akka Streams. But again, won't go into all the detail now. Microprofile, again, it's focusing on microservices, and it integrates very well with Open Liberty, makes use of Mutiny for its reactive operators. And this thing is just quickly too about the microprofile, reactive messaging. I'm highlighting it because at my company too, we have folks actually, the Eclipse Foundation, we're contributing to microprofile. So I would encourage you, if you are kind of looking into building up microservices, that will be a good choice for you. That would also support reactive messaging. And then RSocket, that one, actually, I can kind of share with you. I recently did a talk at another conference together with Oleg from the Reactive Foundation to teach a Pacman to play, like, you know, to play a bot. It's basically making use of Reactive Streams, and we had example of using RSocket. So it's a bit lower level, RSocket. And it supports, like, you know, multi-distributed streams processing very well. Okay. All right, so this is just a slide about RSocket and the Reactive Foundations and the companies that actually in the consortium who started it. They are all listed here. So, and one additional note is that when we talk about streams, we also do not want to forget about OSGI. If you're familiar, if you use the Eclipse IDE, then it's actually all like behind the scenes, all the libraries framework, right? Fundamentals are OSGI. So OSGI also has a push stream kind of spec too. It actually has its own implementation as well. But the nice thing about it is there's no dependency on other OSGI framework in order to use it, except for OSGI promise. So that's just an example for you. So these are like comparison between the two reactive streams and versus the OSGI push stream. One thing to note is that in push streams, the OSGI, you can actually, you have the control of closing your streams, whereas in reactive streams, it's actually, you work through the subscription and you don't have direct control to close it. So that's the one difference. Okay, now let me then go into the sample test case. I realize I only have maybe 5 minutes. So, all right, let me, I do have to exit this and then get into my code. Okay, I have some reactive operators, but maybe I won't go into that part. But the thing is, I wanted to kind of highlight a bit is the vertical from Vert.x. So one good short note or quick note about introduction to Vert.x, which actually I've been doing a live coding weekly on Twitch from through IBM developer on Twitch. I was talking a bit about Vert.x earlier, so I like to kind of point that out. So for Vert.x, it's interesting too. The way it does is that it supports reactive streams, but the thing is with Vert.x, it has its own event bus, so it's very efficient. And again, if you want to start with it, I'd say it is a kind of a good library to start with because it doesn't have as much, some of the other, libraries. For example, with Akka, it's great too. But I think Akka is harder to start with, to be honest with you, because everything's got to be implemented as actors. And not to say it's difficult, but it's just it requires a bit more work. And plus, it also require that to be tied in with a cluster, or like if you want to have it deployed to Kubernetes. But for Vert.x too, you can just run it, right? And here is an example, locally, run it in main. So idea is that Vert.x is all you need to do is a control center. You can just do a .Vert.x and it brings up your control center. And then you can say deploy vertical. So I think it's pretty lightweight in that sense because as you can see in a Hello World example, it extends abstract vertical. So as you can see too, actually over here it just happens my library is out of sync, but otherwise too, it would show you. That's how you implement a Vert.x vertical. And over here too, a simple example would be Vert.x setting a timer. So you can then make use of their set periodic and then basically set. For example, here is 5,000 milliseconds. It's like setting 5 seconds. How would you do this timer? And then another common way of doing thing is to do a Vert.x and then create your HTTP server listener too. So every time you do a Vert.x, then you also have to write a handler to handle your particular call. In this case, this handler in this case essentially making use of a lambda, and it just prints out hello in this case, and then also binds it to port 8080. Essentially what it is. Do I have Sandeep? Am I kind of over time now? So okay. I think, okay, all right. I thought Sandeep was talking to me, but okay. All right, so that's that. And actually, another thing I wanted to point out is that Vert.x, I kind of get excited because it supports like Polyglot, this paradigm very well too. So this is just an example. Like I said, I worked on this. It's still in progress. In the meantime, I will get back to it probably in the new year. It's a bit more like this example. Let me kind of go back and where is my PowerPoint slides? Oops. Okay. Let me kind of go back in here now without getting into all the details. So that was just the example of maybe since there isn't enough time, I will just, I'm so sorry. Let me, I think I clicked the wrong thing, but I think it's faster for me to get into here. Okay, so just a polyglot capability of Vert.x is basically when this example is that I do a API gateway. It's basically funnels the request. So as you can see, the Vert.x, I started up and basically I deployed a vertical. So all of these individual worker verticals can be implemented, just extending abstract vertical. And the main one, all it needs to do is deploy each one of them accordingly. And there you can then have your same Vert.x runtime and be able to handle multiple languages runtime within it too. So in this case, I have an example of Java worker vertical, and also a Kotlin and also JavaScript. And for JavaScript, I'm making use of a sock.js bridge in there. So that's an example, and I can, like I said, I can share that on GitHub to show it to you. So, okay. So, and I realize time is running very short.
You are actually out of time. 30 seconds.
10 seconds? Okay. Okay.
Yeah.
All right, then. Let me just quickly then thank all of you. I know it seems like kind of a big rush. It's just I kind of get excited wanting to talk more, but okay. But the thing is, wanting to thank all of you for having joined this stream. I hope it is helpful. In some ways, I don't feel it's like a definitive way of doing things, but really want to introduce you to all of these possibilities doing streams, and also to invite you to all to continue the conversation. So if you want to stay in conversation, I have a Discord Discord server too. If you want to scan and join my Discord stream, or over here, just click on it and join. And my Twitter handle, GitHub, and my dev.to, I promise I will fill up with more blogs in 2021. So, okay, and these are the different links too. So I'll make this available to the conference organizer, or maybe I'll post it on our link, so then you can get to the slide deck. I also would like to invite you to sign up for our IBM Java newsletter too, and you can unsubscribe at any time. There are other topics too from our IBM newsletter series too. So, and here, please, if you'd like to sign up for an IBM free cloud account, this is the URL and also the QR code. And these are some of the Reactive Streams resources of all of the libraries that I've touched upon. So if you want to look at it, including now I have Mutiny too. So, okay. And also my live stream on Twitch, like I said, is on Wednesday about 12:30 GMT -6, so Central Time. So, and with that comes to an end. And thank you so much, and I appreciate all of you for having joined. And thank you, Sandeep, again for hosting me so graciously.
You're welcome, Mary. Thank you very much, Mary. And Mary will be available on Spatial Chat. So please proceed to Spatial Chat, look for the happiness room, and Mary will be there shortly.
Great.
Thank you, Mary.
Right. Thank you, Sandeep. Okay, bye-bye.
Bye.
Bye-bye. Let me stop share. Okay. And I will exit this now. So, okay. Bye-bye.